Now let's practice using this formula. If you're watching this slide and you haven't tried these yet, you should always try these first before you watch the solution. I'm wondering whether you have the formula on your notes. There's only one way for me to check, so let me do that right now. I may or may not leave this on the thing. Let's see. These are the notes that I've sent you in multiple ways. Oh, yes, you do have the formula, so you can refer to this formula when you're doing these problems, certainly. I, of course, have the formula memorized, so I will simply substitute 5 for n. n minus r will be 5 minus 3, so 5 minus 3 factorial multiplied by r factorial, 3 factorial. So when I expand this 5 factorial, I've got a couple different options. I know this is going to be 2 factorial. I can see that that's 3 factorial. I'm just going to expand my 5 factorial up to this point, whichever one is larger. And then I will simply cancel that one in my denominator. But I still have this 5 minus 3, so I need a 2 factorial down here. The 3 factorials cancel, and I get 5 times 4 over 2 times 1, which of course is just 2, and so that becomes 10. So anywhere you see a 10, you should put an R. There it is, R. T, 14 is N, R, 2 is R. Another way to remember which is N and which is R, N is the full set, so N should be the larger one. But N comes before R in the alphabet, so maybe that's helpful. Alphabetical order, N before R. So I have 14 factorial over 14 minus 2 factorial, 2 factorial. 2 factorial is not too helpful as far as canceling, but 12 factorial is. So I'll do 14 times 13 times 12 factorial over 12 factorial times 2 times 1, just expanding this 2 factorial. The 12 factorials cancel. The 1 divided by 1 won't change anything, and 14 and 2 have a common factor of 2. That becomes a 1, that becomes a 7, and 7 times 13 is 91. So anywhere you see a 91, you put the letter T. There's 2 of them right there and there. Try the next one on your own, and then watch the video to check your solution.